Good morning, dear students, and welcome back to online video classes. In chemistry, we have started chapter 3, atoms and molecules, and we have discussed about the properties of atoms and the subtopics related to atoms. As we discuss the atoms, we refer it to with the building blocks of an anthill as such small sand particles and bricks as the building block of a building. Similarly, atoms are the building blocks of matter. Atoms are indivisible particles that cannot be destroyed or created by any chemical means. According to Dalton's atomic theory, all matter is made up of tiny particles called atoms. This would mean that a rod of iron is made up of millions of atoms of iron. As we consider the size of an atom, we can see that atoms are very small in size. They are not visible even under a powerful optical microscope. The size of an atom is indicated by the radius of the atom called the atomic radius. It is often expressed in nanometers. So, atoms cannot be seen with naked eyes. However, the usage of modern techniques has enabled us to see the surface of atoms. The magnified image of the surface of silicon atoms is shown in the figure. Hydrogen atom is considered as the smallest of all atoms. This table lists the atomic radii of some elements, such as of hydrogen, the atomic radius is 0.037 nanometer, of hydrogen 0.074, of iron 0.126 nanometer. As the size of an atom is indicated by its radius, which is also called as atomic radius. We also discussed about the atomic mass. Mass is the characteristic property of matter. Hence, the atoms present in matter also possess mass. The mass of an atom is known as the atomic mass. Atoms of a given element are identical in shape, size, mass, chemical properties, etc. Whereas atoms of different elements have different masses and chemical properties. Since it is difficult to determine the mass of an individual atom, the relative atomic mass can be determined by comparing the mass of a particular atom with that of an atom of a standard reference. The unit mass of an atom is atomic mass unit, expressed in AMU. Initially, John Dalton suggested that the mass of a hydrogen atom be taken as a standard reference of atomic mass unit. Later, 1/16 of the mass of an oxygen atom was taken as the standard. But in the year 1961, IUPAC, International Union of Pure and Applied Chemistry, adopted 1/12 of the mass of a carbon-12 isotope as the standard unit to measure relative atomic masses. IUPAC named this unit as Unified Atomic Mass Unit, which is expressed as U. So whenever we do express atomic mass of atoms of elements, it is either expressed in U or AMU. Thus, atomic mass is considered as equals to 1/12 of mass of carbon 12 isotope atom. So 1U is equals to 1 by 12 into 12. Hence, the relative atomic mass of the atom of an element is defined as the average mass of the atom as compared to 1/12 the mass of one carbon 12 unit. And for example here, atomic mass of oxygen is therefore 16U. We in the last class also had seen the atomic masses of the first 20 elements in a tabular form. Here also we have some examples of atomic masses of some common elements in the same following tabular manner, where hydrogen's atomic mass is 1U, of helium 4U, carbon 12U, nitrogen 14U, oxygen 16U, fluorine 19U, neon 20U, potassium 39U, calcium and argon 40U, iron 56U, copper 63.5U, zinc 65U, and bromine 180U. Where we consider these atoms and the masses of atoms as atomic mass, we also can think of how do these atoms exist? That is, existence of atoms. So today we'll continue with existence of atoms. The atoms of only a few elements, basically noble gases such as helium, neon, argon, krypton, xenon, etc., are chemically unreactive and exist in free state. That means they have single atom which can remain as in the free state, whereas atoms of most of the elements exist in the form of molecule or ion, since they are most reactive. For example, hydrogen, oxygen, chlorine, etc. are the examples of reactive atoms of the elements which cannot remain single as in the free state, so to combine. Atoms of some elements, as we say, of non-reactive elements exist in free state in nature. So usually the atoms which are reactive and are not existing as single atom are existing in following two forms: in the form of molecules, in the form of ions. In this chapter, we have to study about the existence of atoms both as in the form of molecules first, as well as in the form of ions. Molecules and ions. The smallest particle of a substance is called an atom. An atom is very small in size and it cannot be divided further. Although atoms are the smallest particle of a substance, atoms of most elements are not stable and cannot exist independently. Therefore, two or more atoms of same or different elements combine to form a stable entity called molecules. Hence, a molecule can be defined as the smallest entity of a substance, elements, or compounds capable of independent existence. Molecules can be of pure substances only. The constituting atoms of a molecule are held together by strong attractive force. For example, hydrogen molecule in which two hydrogen atoms are chemically bonded. Similarly, hydrogen atoms can only combine with oxygen atoms to form water molecule when bonded chemically. A molecule is the smallest particle of an element, also of a compound, that can exist independently and possess all the properties of a substance to which it belongs. Chemical physical properties of the substance is therefore determined by the molecule in its pre-independent state. A molecule is a group of two or more atoms that are chemically bonded together and tightly held together by force of attraction. We can see in the box a few examples of molecules of different pure substances: hydrogen, oxygen, nitrogen, and chlorine, represented by H2, O2, N2, and Cl2 respectively, is formed by two atoms of the particular element and is bonded together to form the corresponding molecules. Whereas dissimilar atoms, when combined chemically, these form the molecule of compounds. Like, for example, an atom of nitrogen and oxygen combine to form nitrogen oxide. Two atoms of hydrogen and one atom of oxygen combines to form water molecule. An atom of nitrogen, when combines with two atoms of oxygen, forms nitrogen dioxide. And lastly, when an atom of carbon combines with two atoms of oxygen, it forms a molecule of carbon dioxide. So we can say in elements, two or more similar atoms combine to form a molecule, whereas in compounds, two or more dissimilar atoms chemically combine to form a molecule of compounds. The molecules of an element are composed of identical atoms. For example, an oxygen molecule O2 consists of two oxygen atoms, and a nitrogen molecule consists of two nitrogen atoms. N2 and O2 are therefore called diatomic molecules. So a molecule which is formed by two identical atoms are diatomic molecules. Thus, the atomicity of nitrogen and oxygen is 2. When three atoms of oxygen combine, a molecule of ozone, O3, is formed. Here, the atomicity of oxygen is 3. So we can define atomicity as the number of atoms constituting a molecule is known as its atomicity. The atomicity of some common elements is given below. The elements are non-metal. If we consider helium, neon, and argon, as these gases or nonmetals are non-reactive, one atom, a single atom, can exist independently. Hence, their atomicity is 1, and therefore also are known as monoatomic molecules. Oxygen, hydrogen, nitrogen, chlorine, fluorine are of a molecule combined by formed by combining of two atoms chemically is diatomic. Atomicity will be 2. Hence, these molecules also are known as diatomic molecules. Phosphorus. A molecule is phosphorus is formed of four atoms of phosphorus bonded chemically. Hence, its atomicity is 4, and the molecule is also known as tetraatomic molecules. Sulfur. A molecule of sulfur is formed of 8 atoms of sulfur combining chemically or bonded chemically. Hence, its atomicity is 8. The particular molecule is also known as polyatomic molecule. So, on the basis of atomicity, a molecule of an element can be classified as monoatomic, diatomic, and polyatomic. Monoatomic molecules will have one atom only in its molecule. Diatomic molecules will have two atoms, similar type of atoms, bonded chemically in it one molecule, whereas polyatomic molecules will have more than two identical atoms bonded chemically in its one molecule. Molecules of compound. Atoms of different elements join together in definite proportion to form molecules of compounds. Like, for example, an atom of calcium combines with an atom of oxygen to form calcium oxide. Two dissimilar atoms are combining. Here, therefore, atomicity is 2 diatomic molecule of compound calcium oxide. Two atoms of hydrogen combines with one atom of oxygen to form water molecule H2O. Atomicity is 3, hence water is the example of triatomic molecule of compound. An atom of nitrogen combines with 3 atoms of hydrogen to form a molecule of ammonia, NH3. Atomicity is 4. Hence, it is the example of tetraatomic molecule of compounds. Two atoms of potassium combines with one atom of sulfur and four atoms of oxygen to form a molecule of potassium sulfate, K2SO4. Total number of dissimilar atoms are 7. 2 plus 1 plus 4, 7. Hence, this is the example of polyatomic molecule of compound. The molecules of a compound are formed when atoms of different elements combine chemically in definite proportion. For example, molecule of carbon dioxide consists of one carbon atom and two oxygen atoms. Therefore, the ratio by number of atoms present in the molecule of carbon dioxide is 1:2. This means that the ratio by mass of atoms present in the molecule of carbon dioxide is 3:8. When we consider 12U as the atomic mass of carbon and 16U multiplied by 2 as two atoms of oxygen are present, 32 total atomic mass of oxygen atoms. Here, 12U and 16U are the atomic masses of carbon and oxygen atoms respectively. This given table illustrates some examples of molecules of compound. Water, hydrogen and oxygen elements combine in the ratio of masses of atoms as 1:2 and their atoms are in the ratio 2:1. Atomicity 3. Ammonia, nitrogen and hydrogen combine in the ratio of masses of atoms 14:3 and ratio of atoms 1:3. Carbon dioxide, the combining elements are carbon and oxygen. Ratio by mass of atoms 3:8 or 3:8. Ratio by number of atoms involved of elements 1:2. Carbon monoxide includes combining elements carbon and oxygen. The ratio by mass of atoms 3:4. Ratio by number of atoms 1:1. Hydrogen peroxide have elements combining elements hydrogen and oxygen respectively. Ratio by mass of atoms include 1:16 and ratio by number of atoms 1:1. Molecules of subcompounds are mentioned here with their combining elements. Water combining elements are hydrogen, oxygen, ammonia, nitrogen, and hydrogen. Carbon dioxide include combining elements carbon and oxygen. Hydrogen chloride, and when in the liquid state known as hydrochloric acid, has combining elements hydrogen and chlorine. Methane gas is the combining element carbon and hydrogen. Ethane, again combining elements are carbon and hydrogen. Sodium chloride or common salt has combining elements sodium and chlorine. Copper oxide has combining elements copper and oxygen. When we consider the properties of an atom and a molecule, we see the following differences between them. As we consider atoms, atom is the smallest singular entity of any substance, consists of subatomic particles, protons, electrons, neutrons, not stable alone, often cannot be separated into subatomic particles by chemical reactions. Whereas when we consider molecules, molecule is made up of two or more atoms, consist of more than two atoms which can either be of same element or of different elements. Molecules are stable alone and can be separated into atoms by chemical reactions. Elements and molecules and compounds also do possess the following differences. If we consider an element, it is a chemical substance that cannot be broken down by chemical means. There are 118 known chemical elements, contain a unique atomic number, and contain similar atoms in it. Elements can form different types of chemical bonds depending upon the configuration and stability. The examples include oxygen, hydrogen, nitrogen, zinc, etc. When we consider molecule, a molecule is a group of two or more atoms chemically bonded to each other, similar or dissimilar type. Substances composed of two or more atoms chemically bonded to each other. Molecules can be either homonuclear or of similar type or heteronuclear of dissimilar atoms. Molecules can have atoms of either the same element or different elements, can either covalent bonds or ionic bonds. Example, oxygen, ozone, carbon dioxide, sulfur dioxide, etc. Whereas when we consider compounds, a compound is a chemical species formed when two or more different atoms join together chemically. Substances composed of two or more atoms of different chemical elements. Heteronuclear molecule, as different atoms are present. A compound has atoms of different elements. A compound can have covalent bonds, ionic bonds, and the examples include sodium chloride, calcium carbonate, etc. So today we discussed a molecule as an aggregate of two or more atoms in a definite arrangement held together by chemical bonds. Example, hydrogen molecule, water molecule, ammonia molecule, and methane. A diatomic molecule contains only two atoms, like for example, a molecule of hydrogen, nitrogen, oxygen, bromine, hydrogen chloride, carbon monoxide. A polyatomic molecule contains more than two atoms, like for example, ozone, water molecule, ammonia, and methane, where ozone contains three atoms of oxygen, water molecules contain two hydrogen atoms and one oxygen atom, atomicity 3. Ammonia contains one nitrogen atom and three hydrogen atoms, atomicity 4. And methane contains one carbon atom and four atoms of hydrogen, atomicity 5. Now in our next class, we'll discuss about more properties of molecules. Thank you.